Hello, and welcome to our NAE Grand Challenge of restoring and improving urban infrastructure. Infrastructure is quite literally a part of a person's daily life, from water and sewer to railroad tracks. The current state of our infrastructure is crumbling and aging because of the lack of creativity, changing design, and modern materials. This challenge topic of restoring and improving urban infrastructure really focuses on what are new ways to improve design and have more sustainability. The data we chose was the 10-year rolling monthly generation by facility, which specifically focuses on hydroelectric power and the generation by each plant. We created an algorithm to calculate which facility is underperforming and determine which facility is performing efficiently so that facility can be used as a model, especially in urban areas that don't meet the generation needs. This could help make improvements to the infrastructure and have energy that is more sustainable and widely used and accessible to everyone. Our code is immensely long because we had to do basically the same thing 10 different times for each of the 10 different power plants. Whenever we're calling the data that we need from our Excel document, we are looking at the specific cells within this Excel document. We're going to output that to Alcova Raw, in this case for our first power plant. From Alcova Raw, we need to take the 6th column. The 6th column is the is the net generation per month. So now all of this code right here is for Alcova. This section is for year 2000, 2001, 2002. So that way we can take the average by summing all of the months together, dividing by the number of months in 1 year. Then we do the same thing for Thompson. Thompson Raw, we need the 6th column, and it is from the same Excel sheet. However, our cells have changed slightly. Now we do the same thing for Thompson, we do the same thing for Boyson, Bill. We keep going for each of the 10 different power plants. Should have probably made this a function so that way it would have been easier, but at the time we didn't exactly know what we were doing. Now whenever we get down here, we're going to go ahead and plot all of the data that we previously just found onto a bar graph. This bar graph goes from years 2000 to 2008, and all of this data for Y1 is Alcova, Thompson, Boyson, Bill, Ferry, Esses, Vermont, Glendo, Green, and Gunnersey. This subplot is plotted on a 2x5 subplot. Each plot is labeled the power plant. For our part 2, we are taking the averages from each plant per year. So this first line is for year 2000 for Alcova, Thompson. We're just adding them all together and dividing by the number of power plants that we have, which in this case would be 12, or my bad, 10. We do this for each power plant for each year. And then we'll go ahead and plot this again on another bar graph so that it is visually easy to see. Then our part 3 is to determining through a user-defined menu window whether that plant per year is performing above or below the overall average. The overall average can be taken from the histogram that we had shown in part 2 and then applied to part 3. Where you're saying that if user is entered 1, which would be the first choice of Alcova, then it goes into this first section. And now for each year of Alcova, we determine if the Alcova average for that year is above the average net generation for the whole year of 2000. If it is true, then the Alcova plant is performing above the average in year 2000. If it is the exact same number, highly unlikely, then it's performing the average. And then also, in the last case, it is performing below average in the year 2000. Now we do this for year 2000, 2001, 2002, all the way up to year 2008. And then finally, we determine if the Alcova average generation for all years is above or below the overall average. Now the user chose option 2, which is Thompson, then it goes through the same code that we had just ran for Alcova. For year 2000, 2001, all the way to 2008. After all these if and else if statements, we get to part 4, which is the best overall generating plant. We do that by taking a plant matrix of all the different averages of plants and finding the max from that, which will be the best performing plant. You can also view that by looking at the first bar graph figure that we had shown. And you can see that by looking at the data on the y-axis, that Canyon Ferry is the highest performing plant in terms of kilowatt hours produced.